Okay, so yes, let me know once you can see my screen. Is it visible?
Yes.
Okay, thank you.
Yeah.
So yes, welcome everyone to the ABAP on HANA session 1, week 1. Okay, so our pattern, or we can say, yeah, the sequence of each of the session that we would be having is we would be going through the agenda for each day on the session. So we would be having an overview of okay, what is something that we would be learning during that particular session. In the all upcoming session, we would be going with a recap of what we did in the earlier session. So definitely today is our first session, so we won't be having a quick recap, but instead we will be starting with something new. And then mostly we would be learning with all the practical aspects, mostly going around the uh, development part only. So we would be going less theoretical and more practical. And one more important thing is during the session at any time, if you feel you have any question, you do not need to wait for any sort of you do not need to wait for me to ask if you have any question. You can interrupt anytime and we can have that open discussion. Okay. So yes. So let's just start with today's session. So we would be going with the quick agenda. So the agenda for today's session is what is ABAP on HANA. Okay, that is something why we are all here. And then we would be learning on the certain programming methodology. Why it is important is you might have heard that these days object oriented is very much into discussion. So if you see all the companies are asking whether you have experience in OOPS and all, that is the first thing. And second, why we do have most importantly over here is that uh, we have one of the HANA artifact which is mostly developed using OOPS concept. So we have both the flavors. Our new ABAP syntax is mostly on both. It's a procedural as well as OOPS. CDS is mostly a SQL level development, and the AMDP is mostly on the object oriented. Okay, so we would be getting the idea of how the execution occurs. In deeper manner, we would be going as and when the requirement occurs. Okay, so that is something on the programming methodology we would be seeing. Then we would be developing certain programs for the old and new ABAP syntaxes. Okay, to identify what all differences we can expect, and we would be learning in that duration two main sort of new ABAP syntaxes. So today our main agenda would be learning open SQL, or you can say SQL level new ABAP syntax. Going forward, we would be going with a we can say application server level or the kernel level ABAP syntaxes as well. So we would be starting with something called inline declaration, then the open SQL syntaxes, and we would be seeing how the open SQL syntaxes that we are learning with very minor adjustment, 90 to 95%, they are also matching of the of the CDS based development that we would be doing. So ultimately, we won't be going deeper into CDS, but we would still be seeing, okay, the new ABAP syntax that we are learning, is it aligned with the upcoming HANA artifact or not? And then, of course, whenever something new comes, it doesn't mean it would override each and everything that is there till date. So ultimately, we would be having some sort of discussion on what is the limitation, and at that particular point in time, we can choose to go with the native SQL as well. Okay, so that would be the agenda. So I'll be just quickly go through. Sorry, yes, we are already on the slide. Yeah. So, and if time permits, then we would be going with certain application server level syntax. So let's just start with a brief question or what we had already discussed during the webinar. So this is the only slide that we are having. Next to this, we won't be going with any slide. Okay. So what is ABAP on HANA? So whenever SAP HANA comes, we might have experienced, or we can say we might have heard certain things. So when I say I do have a SAP HANA, okay, I'll just throw one more box to also visualize what we were doing till now. So ultimately, I can think of that this is my SAP ECC, and I can think of this is my SAP HANA. So if I consider this as my S4 HANA, definitely I can consider it as a higher on NetWeaver version first. And the very important thing over here is the HANA database. So ultimately, DB we are having over here is called HANA DB. Okay. In SAP ECC, definitely we would be on some sort of SAP ECC version starting from 6.0 to 7.4, anything. So we would be having some sort of SAP ECC version starting from 6.0 to 7.4 or anywhere. And we might be working on some sort of database called Sybase. We might have Oracle, and many SAP system has already migrated themselves, but only activated HANA for that. So ultimately, we might also see certain ECC system where we do have a database which is a HANA database. So whatever new syntax that we would be seeing would definitely be applicable for those SAP ECC where HANA database is also there. Depending on the version of the system, certain syntaxes may or may not support. Okay. Let's just think of the architecture. Let's just think of the old ECC days. We were asked by when we were trainee, we were asked by our senior, and now we are asking our juniors. Okay, so we are asking them that if we are on ECC, use as much as we can say application server and avoid loading your database. So it means you might have seen that you are always asking them to avoid the joins. Okay, you are asking them to use the for all entries in. You are asking them to not use the group functions. You are not asking. You are asking them to use very we can say individual queries and load your application server as much as possible. Why? Because if I visualize my server as two component, okay, if I visualize my server in two component, then this is something I can consider that my capability of my application server was kind of at 70% of the system or 80% of the system, whereas the capability of DB was very less compared to that. Okay, and it is just for the means of storage. So ultimately here we are only using the database just for the means of a storage. So the data would be stored, the table would be containing all the set of data and everything. But when it comes to a HANA database, it's totally other way around. Here, definitely application server has the same capability as it was having because it's the same application server engine. But as a database server's capability is increasing, if you compare it into 100%, ultimately we do have now application server less powerful than that of the database server. And this database server has now two sort of capabilities. One is called storage that ultimately each and every database has. So ultimately, if you can think of a normal Google Drive or any sort of storage device, or let's just say if you consider your laptop as well, where we do have certain sort of hard disk, that is a kind of a good example of a storage. At the same time, we do have in our laptop. So these I can consider it's your hard disk. Other than that, we do have something called a RAM. Okay. So I can say in memory capability, or I can term it as a some sort of RAM in terms of a laptop. Okay. So this capability which a particular HANA database is having, or we can say S4 HANA system is having, is making it far versatile than that of the SAP ECC. And that is why when I say that, okay, I want to deliver a task in a better way, in a performance efficient manner, what I'll be doing is I'll be using my more powerful resource. If someone wants to deliver his project in a earliest at earliest point in time, what we would be doing is we would be mainly asking our most strong candidate to ultimately work on that. Okay, because we want that particular task to be done at earlier stage. Okay, let's have a minute of break. We have Rahul over here. Hi Rahul. Okay, issue with his server. Fine. So ultimately, that is what the system we are doing over here. We know that our database is very powerful, and that is why what we are doing over here is we know if our database is very much powerful, let's just database do all the complex execution, all the complex code level execution for getting the data, furnishing the data, preparing it in the format that the output user needs. All the processes that used to take time, we are asking my database system to do that. Okay. So ultimately, we are having all the complex calculation being done on a database server over here. This is my new way of programming, or we can say a code to data approach. Okay. So you might also have heard this question, what is a code to data technique? What is a code push down technique? So main crust over here is we are possibly shifting all our execution mechanism to the database because we know the capability of this database is very huge. Okay. And we used to do the data to code approach earlier. So we used to follow this approach where the data to code means we are just fetching the data from the database and rest all the calculation, rest all the manipulation, readiness of the data. We used to use the application server for that. Okay. Because my HANA server was not that capable. And here we do have that capability. So let's just learn one more thing over here. So we learn the capability wise, it is far versatile than that of the ECC. Now, as we talk of
No,
the HANA,
so, it-
yes,
so
Praveen,
sorry
yeah,
for
yeah, no
so it,
issues.
it means it means ki at S4 level, so the code would be directly at the database level itself.
No, the code won't be directly at the database level. So let's just
Okay.
say if you can visualize of a requirement saying, let's just say your requirement is to get some sort of data. Let's just say you want to get some sort of PO data. Now,
Okay.
definitely in a database, I would be having the data stored in a more optimized way or in a row manner. But my user won't always need that. Okay. So for that, I might do some sort of, let's just say, operations for some sort of manipulation of the data in a string format, or I can say any sort of arithmetic or any sort of operation. Or let's just say sometime we might need to do the currency conversion, quantity conversions. Many a time what happens is after getting all the set of data, we might need to use let's just say in ACP ECC what we might have what we used to have is we used to have, let's just say 5 different internal tables, and we used to directly get 5 internal tables. Then we used to merge those by processing all 5 internal tables internally, and we are finally deriving it one set of output that we were ultimately presenting it to the user. So we might not have at the database level all the data that we need in a format and in a single place, and that is where we used to use the application server. That application server would do the task of merging and finalizing and formatting the data in a form that the user needs, and that particular task we are ultimately now pushing as much as possible to the HANA database. Okay, so all the execution, or we can say calculation or manipulation wherever possible, is something that we are forcing the database to do. But one but is over here that my SQL syntax and my application server syntax are different. Now, application server syntax, is quite versatile because it has very much liberty, whereas SQL is always following some sort of RDBMS concept. Now, as it is following some sort of RDBMS concept, many things would be there which cannot be done at the database level. And that is why we also need to ensure that the application server we are following, the syntax of application server we are following, is also done in an efficient way. For example, and that is why we are having the new ABAP syntax is also over here. So it doesn't mean whenever we have a new ABAP, or we can say HANA, everything would be done in database. I am saying possibly wherever the data readiness is concerned, as much as possible we would be preparing those data, the readiness of the data we would be trying that it can be done on the database. If it's not, then application server is there, it has far more capability. For example, in many of the interview we might be asked that, okay, I have a one header data, one item table data, I want to do some sort of correlation. How would you write your logic? So we might end up with a logic which goes with 100 iterations. But the efficient one is something that can also ensure that though we do have 10 header and 10 line item records, okay, my loop, if I can restrict that, it doesn't iterate 100 times, but instead it can restrict to some sort of 10 to 50 iterations, then this is some sort of efficient algorithm that we are writing. And that is where we do have a new ABAP syntaxes of application server level coming into picture. So this particular execution cycle, if you see, this is something that we are doing on the application server. We have far more capability on SQL, so we are doing it on the SQL server. The only ask is that we would be ensuring that who is the powerful candidate for executing a particular task. We would be just picking that right set of tool to get the task done in an earlier manner. But yeah, to answer your question, it doesn't mean we would be doing each and everything on the database and we would be just directly handing it over. It's a possibly maximum execution. We are just handling, asking the database to handle that.
Okay. Okay.
Okay, thank you. Now, let's just learn on to one more task over here saying in memory. This is something we are doing. So let's just say I had a requirement of getting some sort of data, okay, and I derive it for let's just say PO number one. I derived that particular set of data, and it is relying on it is lying somewhere in the RAM memory right now. So next time, if someone queries that set of data, my system does not need to go to the database. So it's a kind of thing that you do not need to go to factory to derive to get the information that you want. Instead, you have multiple sales agent waiting at your doorstep, so you can have that particular execution task done at the earliest time possible. Okay, so that is something that the system is also doing. So RAM in memory computing is something that ultimately giving a system capability with a set of RAM installed on a HANA database. And that set of RAM is, of course, very expensive when it comes to a costing. And that is why HANA server is a bit higher on the costing side whenever it comes to SAP ECC. And that's why we see the projects are thinking too much whenever it comes to a HANA database. But yeah, it contains 10 to 100 times, or we can say 1,000 times um, capability of executing, or we can say calculating certain complex things on the way, or we can say on the go. Now if I'm getting one set of data I do have available in memory, so next time if I do have some sort of RAM memory over here and I do have some sort of database memory over here, reaching out to RAM and getting the data is far more quicker compared to getting the data from the database. And that's why if we do have something already loaded, then the system would be doing it over there. Whenever it comes to a CUD, the create, update, delete, the same concept would be followed. The system would only go to the my RAM memory and it would ensure the completeness of the data internally, and it would ultimately load it in the RAM. So execution of, we can say, or we can say the reflection of the RAM data to the database is being done by some sort of batch process internally, some sort of HANA batch processes internally that ultimately it won't be visible, or we can say it won't affect the regular execution which a actual user is doing. So it won't be part of his session. Instead, there are multiple work processes already going on, which is taking care of this particular sync between the RAM and the database. Okay, so once we have any sort of operation being done, at next particular point in time, the updated record would be loaded into the RAM, and thanks to those in between running batch processes which are there. And that is why this particular execution cycle would be followed. It's not your database that would be triggered each and every time. Wherever and whenever possible, your execution would hit your RAM memory, the in-memory storage, which is there in the HANA database, and not the actual hard drive storage. Okay. Now, one important thing over here we do have is the setup of the system. This all the things is happening because of, okay, in ABAP on HANA, we do have some sort of a good mechanism that we had already discussed earlier called a storage type. Okay, so whenever it comes to a HANA, the storage type over here, as you can see on the any of the HANA database tables, storage type as a column store. First and foremost thing is the storage type that you are setting over here you have to set it for all the tables. So ultimately, storage type is automatically set. Okay, it's automatically set, and it is a setting at the database level and not at the table level. That is why you see it's a DB specific property. So whenever there would be a set of customizing which a basis person would be doing whenever he is setting your HANA database, or we can see your S4 HANA system, the execution should occur on a column store. The advantage over here is, let's just say I do have a set of data. Let's just go over here. Here, what is a primary key we do have? It is EBELN. So we know if I'm querying my database on EBELN, I can expect my execution to return me with the data in millisecond or microsecond. But whenever I am querying on any sort of other information, for example, a listener or a language or any sort of other information, it might take some time. Whenever it comes to SAP ECC, whenever it comes to SAP HANA or S4 HANA, the system is designed in a way that all of its particular columns, or I can say all of the tables, we can say well-defined columns. Let's just say well-defined column, it means the columns which are having its data type plus its length limitation specified. Okay, whenever I do have a column which is having a data type well defined, saying whether it's an integer, character, or number, as well as its length defined, at that particular point in time, system would generate a dedicated index table for that. So ultimately, I can visualize the EKKO table would have 208 number of index table associated with it, which would help the system to do the data compression. Okay, so it would store the data in a manner of a pointer. Where the data compression occurs, what the system would do is it would just say, okay, BUKRS, if it's 1710, for example, then the record is actually being stored. The record which you are trying to look for is stored on a record number 1, 2, 3, 8. Ultimately, any sort of random index it would be storing. Not in this manner, but actually in the object pointer manner. And that's how the system would only store the data in just single row. So whenever your query is saying give me all the data for 1710, it doesn't need to iterate on all the millions of record that we do have this for this particular company code. Instead it would just go to the pointer and get the required record and directly get the required columns information that you are requesting. Earlier we used to have some sort of index mechanism. Okay, so that index mechanism is now getting overruled, or we can say it is now reducing day by day. Okay, and that is why this particular internal, or we can say predefined index is coming into picture whenever it comes to S4 HANA. As I mentioned, the index would be defined on the well-defined column where we do have the data type and length limitation specified, and hence the data compression would occur over here, because if you see the amount of storage that it would pick, or it would take to store the data would be quite limited. But the data type where we don't have this specified, for example a string data type, here whenever you are working on a HANA database, you might get that the query that you are writing on a string database or something where the data compression is not possible, because as if it's a string, I can expect, okay, the user might store 5,000 characters over there and it would be in uppercase, lowercase, it won't be uniform, and that's why data compression cannot occur over there. And that's why the string, as well as you can see the blob data. Blob, I mean I can say content of, let's just say you are uploading an attachment and you want to store the content of the, let's just say PDF or image, anything. It won't be stored in a format of actual image, but instead there would be some sort of hexadecimal content that would get generated, the blob content. And those blob content is also non-compressible. Okay, so these are the non-compressible information. Those would restrict your that particular column from getting compressed. Okay, and that is why string is something that definitely we cannot avoid this, but that's why we are still while defining the table, while if you monitor the table also here, you would be seeing that at most of the column level, wherever possible, SAP has defined a specific length. If it's not possible at some point in time for one or two odd columns, then it's fine. But the content over here is strictly asked to avoid on the database, because as I mentioned, HANA database come with a two component, storage as well as in memory. And that is why the costing of this particular database is quite expensive. So if it is quite expensive, it's like I do have 15 GB of Google Drive space assigned to me. It's on the free level, so I'm using that. But if I am purchasing that particular additional subscription, then also it would cost very minimal to me compared to what I'll be paying for those 15 GB of HANA database storage. Okay, and that is why in each and every project where we do have a HANA database, or we can say we do have S4 HANA system, we would see a DMS server setup as a mandatory. The SAP won't restrict you because it's ultimately the database that you are using. It's all up to your project. But DMS server is strictly asked to use. Reason being, the database that you would be using for the content storage would restrict the data compression, and hence tables capacity would become full as soon as you start using that, compared to DMS server, which is an external file storage server, which would cost you very minimal. And that is why this particular storage should be used whenever it comes to a content, or you can say file upload. Okay, so that is what is the meaning of a data compression. Now let's just go in the system and just see the possible new ABAP syntaxes that we would be using for the whenever we are saying we are on the S4 HANA, we are changing our way of programming. What is something that is changing for us? So I'll just say, okay.
Sumit, I
Yes,
had a
please.
doubt. Can you come
Yeah,
to that in memory thing once?
yeah, definitely. Yeah, tell me.
So
Yeah.
this memory, right? Whenever we are doing any CRUD functionality, any CRUD, okay, let it be write, update, delete. So it directly doesn't happen to the database. So it happens in the in memory. Then a batch processor would be there, which would be updating the DB in the work
So
processes.
ultimately, yeah, ultimately that responsible person, or we can say responsible process for
Yeah,
updating the information on the database is this batch processes. So if you see in SAP, we have multiple kind of work processes, individual work processes which are assigned to your individual session. Saying I am executing something, then I would be having a dedicated session which would complete this whole cycle. It would
exactly.
get the data from application server and reach ensure that it is reaching the database. But here we have to just give it to the batch process, and it would hand it over to that. This batch
Okay.
process is also quite faster. So if you say I am executing and I'm also checking in my AC16 and I'm still getting the data, it's because the batch processes are also huge in number, because these
Number.
batch processes are also part of the RAM. So it is quite faster compared to the normal, we can say, processes that you can think of. And that is why whenever I'm saying I'm executing, I'm saying commit, and I'm checking the database and I'm still getting the data. I'm not sure who updated it. I did my section updated or did the batch process? But in
Okay.
architectural point of view, it's the batch process which is doing the task for you.
Okay.
Okay, perfect. So we would be starting with a new syntax over here.
Sumit, like in table, you said for each field they will, store in the row like 1, 2, 4, like that. It will keep a
It would
pointer,
have
right?
a record pointer for, so that's
Ah.
ultimately, yeah.
It is for each field of the table, or only specific.
It is for each well-defined field. So wherever data compression is possible, you would be having an index table. Wherever data compression is not possible, you won't be having an index table. And that is why if you see, if you are querying or storing, if you are even
Mhm,
querying on the database where data compression is not there, you can observe that your performance is not getting better. It is even getting worse.
mhm. So this it will be automatically created like pointer one.
Yeah, so ultimately, whenever you are activating a table, whenever you are generating a column, the system would generate the index table in the background automatically for that. So very first time you are creating a table, and let's just say there are 5 columns into it, the 5 index table dedicated to it would get created. Afterwards, if you're adding one more column, definitely it would be null initially. Okay,
Mhm,
so let's just say if you might have think of a scenario, or let's just say, if let's just go back to the experience. Let 1 second, and let's just create this program. Otherwise, it would just time out. Just one more important thing. Thanks for asking this question. It just bring me to one more important point over here. Yeah. So here, if you see in older days, what used to happen is, let's just say I do have this table. I have some sort of columns, and now someday I'm getting a issue saying my program is not behaving perfectly. I put a trace. I figured out that it's a EKKO table square, which is making my system to behave very slow. If that was the case, then what we might say, okay, we are saying that it is just a primary key, and the kind of data that we are fetching over here is ultimately not part of the secondary index specified onto it. Now, when I say, okay, if I want to always query on this listener and let's just say ER name, I'll say, okay, can you please create a secondary index on this? We can create, but there would be a huge amount of debate for that. Saying, okay, if I create the index on these two tables, what is the usability? Will it be used more or not? And what is the amount of data that it is currently carrying? Why we do have that sort of a huge amount of debate every time? Do you know the reason? Reason is whenever a index is created, whenever a index is created, the system would, system would create an index table first place, and secondly, the system would also sort your data internally. So it would keep a sorted copy based on those columns you are specifying in index. So system would store a sorted copy of your data. And if it is
With respect
storing
to that,
with respect to that index, definitely. So next time if you are searching for a combination of listener and ER name, then system does not need to go and search for each and every line. Instead, like a binary search that we are using, system know, okay, where to reach out. And that is how the
with respect to
system
that,
can exactly, yeah, exactly. And that is how that is why the iteration, or we can say this sort of sorting of the data should also take place whenever a new index is getting created. And that is why it used to be huge debate, because in between of a project we are coming that I want a new index, and it ultimately needs a reiteration on each of the data and resorting of each of the data. Instead, if we are on HANA, each time you are creating a measurable column, a well-defined column, if it is creating an index on that, what would be the data stored onto that initially? It would be null. So system does not need to sort all the data. What it do is it just put that particular column is sortable, and that's it. Your old data's reiteration won't occur. So going forward, the new data is getting inserted. It would be entered in a sorted manner only in that index table. And that is why SAP is now taking care of those index which you were creating on demand earlier. System is now creating it internally by itself always. And the execution time which used to take place for adjustment of your data using SE14 or something that we were doing earlier is now not required at all, because it's being done when there is no data available in the column, right? And that is why this debate of I need an index column, otherwise my program would become slow, and then that sort of higher management approval and what sort of approval that we are getting from the technical lead is now reduced,
So it will
because
be
we
in the older system, the sorting will be happen when we create index. So it will be
yeah,
one time sorting, right?
it would be one time sorting of the existing data. Going
Hmm.
forward, if I am entering a new record which is not there available in the index table, for example, I'm entering a record for a new
Hmm.
company code or a new listener, it would be inserted at a dedicated place where actually it belongs as per the sorting.
Yeah.
Okay, so it would not be always append, it would be insert at a dedicated place. So system would find out an index and then insert it at the dedicated index. So while at time of retrieval, it would be faster, because ultimately what we need, the retrieval should be faster, because the user 80% of a database activity occurs on a dashboard level of system, where actually the data monitoring is the purpose, data analytics is the purpose. The creation is still a small task, right?
Mhm. But that's what in the older system it will be one time sorting. So if needed, we can do it, but it takes
Yeah,
time.
yeah, definitely. So if you are already working on SAP ECC, you might have encounter that situation that after performance issue, you might come up with a conclusion that I want a secondary index on that, otherwise this query won't work. Because
Yeah.
each time it's not possible that I might have primary key which I need for the input and I do have available like for me as the input. That's not possible each time. Correct. And that's why we have HANA.
Yeah, that time we don't have any option. We have to go for secondary index in that ECC.
Exactly. Yeah, exactly. So let's just start with something for which we are talking of all this while for the advantages. Let's just see it in a live. Okay. Now, we are saying that we do have a HANA project, we do have a fresh HANA implementation or HANA migration project. So we know we can have many a time a requirement saying I do have a HANA project, or we can say I do have an existing project and I want to. So we might see that we might have some sort of project already available with me and I want to enhance it. So I do have a report, I have already shifted it to HANA and I want to enhance it. I don't want to go overnight and just change the syntax. That's also totally fine. So we might have a native SQL syntax available in my report and the open SQL syntax available in my report. So the older one that we were using is called native SQL, which is native to the coding that we are doing, and then it would be converted to my database specific syntax. Now, the syntax that we are following right now is called OpenSQL because it is something which is openly understandable by database. So we are avoiding any sort of conversion in between, or we can say we are avoiding as much as possible the conversion. So certain sort of minimal, let's just say internal table declaration or something we are doing inline, there we'll need some sort of conversion, but still we are trying to avoid it as much as possible. So whenever we are talking of ABAP on HANA, let's just now introduce our main party over here. We do have three kind of artifact. First are new ABAP syntaxes. Second is our own HANA database artifact, very versatile, and it would be used in all the upcoming HANA technologies. Okay, you might have heard many technologies coming on top of CDS these days. Okay, so third is my AMDP. The new ABAP syntax is divided into two parts again. It's called SQL level new syntax, or I can say Open SQL. Plus, we do have many a syntax introduced as a part of new ABAP syntaxes. New ABAP syntaxes are SAP NetWeaver level, or we can say application server level syntaxes. Those ensures that the amount of iterations it used to take for the execution is now reducing. The code line is getting reducing because the compiler needs to scan each and every line. So that is something that we are reducing. So my new ABAP syntax would ultimately take care of the SQL level and the new ABAP syntaxes. That is something that we would be learning during the session. And then at CDS level, we do have some sort of SQL languages that we would be learning, the annotation, associations, and everything from starting to normal report to the we can say browser based technologies as well. So for providing them feed with the data, so for providing those UI application or data services, that is something which ultimately CDS would take care of. That is something we would be learning, and we would be learning whole REST API also for that. Third, and so last but not the least, AMDP is a whole new language called SQL script, termed as a database procedure capable of handling very complex processing because it gives us an intermediate execution area which none of this artifact provide on a database layer. Each and every artifact provide those, but on application server level. Here we do have an intermediate area where the execution can be done on database. But in detail, we would be seeing it practically while learning AMDP, and at that particular point in time, it would become more clear. New ABAP syntax we would be seeing for 3 weeks, for 3 sessions. Then we would have 4 dedicated sessions for CDS because it is having many topics, and secondly, it's very important in our career going forward. And then we would be having 3 sessions for this. So let's just start with this. So in a native SQL, so we are starting with a SQL level, the open SQL syntaxes. Let's just say we did have some sort of already available data available with us. I'll be just going with a very small example because we know older, so I don't want to go more deeper into that. So let's just say I am getting a some sort of data already available with me. And here I used to have some sort of table, which sorry, these my types, these. So I did have some sort of already available code. So I have to respect that. It's because it's not just 5 lines of the code each and every time. There can be a program which is going on from years, and now overnight I cannot change that just because I want to write one query, send it to production. Who did that? We lost everything. Okay, no issues. So ultimately, we are generating a query which is giving us the data in an older way. Now, if I want to get the data over here, what I might have written is, I might have written saying, okay, select me the data. Let's just say BUKRS, and to make this more clear, let's just add one more column so it becomes more obvious for me of what we are planning to do over here. So we are selecting these two columns from here, and we are ultimately getting the data from T001, and we are storing it into a table called LTT001. This sort of query we had earlier, it seems. So this is an older native SQL syntax that we wrote. We had this at particular code line earlier, and now I want to write one more new level syntax saying, based on this, based on the some sort of input, get me the purchase order data. So my next task is to get purchase order data over here. So I'll just say, okay, what all information I do need. So I'll just say I want some sort of purchase order column coming from its EKKO table. But this time I am planning to choose the new ABAP syntaxes for that, the Open SQL. When it comes to SQL, you would be finding very minimal changes. In a sort of application server level coding, there are huge amount of changes involved. Here, a few things would change. First thing that would change is, we can say, column delimiters. From space to comma. If I am saying I am using new ABAP syntaxes now, I would use EBLN dash, or I can say comma, BUKRS, BSART, BSTYP, for example. And here I would be going with the name of the table, and here we would be going with the inline declaration. So we have two options over here. First, we would be learning how inline declaration works, and then we would be going with other one as well. I'll just say into table. Here I'll just say at the rate. So we would be having with each of the variable, or I can say applications of or variables we are using, it should be preceded by a host escape character. So you can think of a class. In a class, if I want to use my global variable and a local variable, then how I can distinguish between both of them? So that sort of super dot, or sorry, this dot and all the variables that we are using over here. The same way, if I have a database level columns, EBL and all, and I am using one more variable for the system, but it's available at application server level, then I'll be using at the rate. For inline declaration, what we would be using now is called a data keyword. So I'll just use a data keyword over here, and here I'll just define a table called LTPO data. And if I don't want a let's just say input for now, so I'll just fine. So this is something that you can think of. So this is ultimately a very minor difference you would be seeing. A comma separator has now been is now replacing the space separator, and the variable is now declared like this. If I do have already available a table, for example, I do have this table LTT all 01, and I want to use it somewhere in any of my other query. For example, uh, use the LTT0, use already existing, or we can say already determined table, or I can say here I want to use a new ABAP syntax for this. So there are two ways saying if I don't have a table already declared, and if I'm using that, then I'll be using @data over here. Instead, if I do have a table already declared and I want to go with a data selection for that, but I want to go with a new ABAP type data selection, then I'll just follow the same rule. I will just say a comma separator for the columns first. If the variable is not declared, @data would follow you. If the variable is declared, just an @ would do this task for you. So this would be converted into a new ABAP syntax is going forward. Now, why it is required? So let's just say in a room there are two different things lying, and purpose of both are the same. So how would you determine that which particular method I want to go for my task? So ultimately, the this select query and this select query both would be doing the same task. But if you want to go with a execution cycle which would hit the index table, which would hit the HANA engine for fetching the data, then you have to go with the new ABAP syntaxes. So ultimately, this would execute the SQL using HANA engine. So ultimately, we do have everything. We do have a index table created. We do have the data stored in a compressed manner. We do have a column store approach also followed. But if you're going by the older approach, then definitely it won't hit the HANA engine because it seems like your SAP ECC syntax. So system would go still record by record and fetch your data. Instead, if you have specified it using a new ABAP syntax like this, then this execution query would go by the index table and not the actual table for fetching the data and give you the right set of data in the output. And that is why just changing this query would also help you improve the performance. Okay. Now, so there are two ways we can say. If you don't have a variable, you can do it like this. If you do have a variable already available with you, then you can go by just using an @. If you just see how ultimately the system is doing, I'll just put a breakpoint over here for first time. I'll just say execute for now. Okay. So ultimately it gives us the same data. Okay. And here it gives us the data without specifying the type. Here we used to have some sort of type. We use the same table, but that's fine. We use already declared variable. That is the main crust. And it gives us all the data in this particular set of output table. So we have two flavors. If we don't have a variable already declared, then you can use @data, else you can use @. Now, the limitations that we were talking about, which says in a particular in SAP, okay, in SAP, we have many places, right? We have many places where we need a dedicated type, I can say, a dedicated type variable. For example, if I say a range, so let's just say I want to search the data in from a particular range, saying, okay, I want a data where my BUKRS is in, I'll just say LR BUKRS like this. So this LR is called a range variable because it's following in. So what should be the type of a range variable should look alike? It should look alike, say, it should have a sign of variable. If it says whether it's include or exclude, then we would be having an option column, then we would be having a low column, and which would be having a high column. The type of a low and high should be same as that of the BUKRS. That is, our structure of a range is actually being built. But when it comes to an inline declaration, for example, I want to select the same set of data but in a range. So I'll just say sign. I'll just say, okay, I'll just say, for example, EQ as option, because what I am willing to do is I am willing to generate this particular BUKRS, a range for BUKRS using inline declaration. So I have I, EQ, and here I do have, let's just say, BUKRS also coming, and I am just using it as a low. I'm just saying from, give me the data from T00, so I'm just filling the data into a table called a range table, and I'm using inline declaration for this. Need a high column as well, but I am going with I and EQ, include and equal to. So ultimately, I might not have a high component available over here, but it's strictly required for a range to be valid range. That high component should also be there. If it's not there, then pass it as a blank. So I'll just say fine. In that particular case, I'll just write, for example, a blank as a high variable. If I just say activate, and if I try executing this, I would get LR BUKRS, which is also having 4 columns. But if you see, it is I, EQ, the data type of low and high is differing. It is character 4 over here because that's a type of a BUKRS, the column which we use from the select query. But here it is a C. And what is C? C1. C1 is a character 1. It's not C4. So low and high column are having two different data types. It means it's not a valid range data type. So at this particular point in time, you have to use a open SQL query in a way that the type of the variable that you need is not altered. And that is why if you see, the limitation of the open SQL is each time inline declaration may or may not help you. Where we need a dedicated type, right? So a range variable has a dedicated type, and if it's having a dedicated type that we need, many a time it's possible that the inline declaration may or may not help you. Let's just say I want to use a 4 character, I might add 4 space over here. But let's just think I am having a material number. So will I add 40 characters for that to build a range for that? That's not practical, right? So for having this output more crust, what we might use is we might break this whole execution into 2 steps. We might declare a variable first. We might declare a variable first, and then we would be using the new ABAP syntax, the OpenSQL syntax. And this OpenSQL syntax would ultimately do the assignment, the data assignment. So whenever we want a dedicated type, what we have to do is we have to execute our, or we can say we have to write our code in a way that the declaration is being taken care by the older manner. So the inline declaration is something that we have to avoid because we need a dedicated type that the system can't actually live without. And here, if I just say definitely as it's a dedicated type, the system would only assign the data to it. The system would only assign the data to it, and we would be having a right set of range. Still, we would be having the values assignment in a newer way. Okay, so you cannot consider it as a 100% limitation, but yeah, a rule that you have to follow for your program to work smoothly. So inline declaration is not something that we would be using always blindly. Okay. Now, one more thing that we would like to go over here is certain more SQL syntaxes. So this is something the basics that we started with. Now, in older days, let's just say we used to have some sort of, for example, we used to have one more important fellow with us called appending table. You might have heard of some sort of appending table earlier, saying I do have. When I say I do have an appending table, what do I used to have? I used to have a output structure. So whenever I say I am using appending table, what I might be using is I would be having one output structure which says you have a set of data available with you. For example, let's just go by the same example, BUKRS and BUTXT. So I do have a company code master coming from T001, and I do have designed some sort of external customizing which is giving me some sort of other organizational unit, and I also want that to be there in my internal table LT org units. And if I have another data source called ZT001 for this, what I would use is I would select the same set of columns again, and then I would simply call both of this query. First select this query, and then ultimately after having the data available, we would be just writing appending table, and we would be writing the second select query. Right. So what we are doing is we are writing a select query over here. We are on the application server for that. Then we are coming back. Sorry, we are on the database server for that. Then we are coming back to my application server. Then I'm again writing a database query. Then I'm coming back to my application server. And at this particular point in time, I would have the data filled from two different data sources. Instead, SAP is coming up with a new keyword called union. SAP is coming up with a new keyword called union for this. And this union would ultimately help us with the set of data that we need from. So union we are getting over here, which is a horizontal concatenation of data. And the data source can be, it can be a same data source with different conditions. Or I can say it can be a different data source. The rule is same as that of the appending table. What is the rule of appending table? That the output data structure that we are using over here should follow. It should be the same. If I am getting 5 set of columns from my first select query, I should always get the 5 columns as my output whenever I am writing my second select query. It's the same. Okay. For example, let's just have a dummy table available. Let's just create a dummy table saying we have some sort of ZEKQ. I remember I had created that earlier. Nice. We do have ZEKQ available, and do we have any sort of data also over there? Nice. So we do have a ZEKQ which is having around 89 records into it, and we do have a EKQ over here which is having around, you can say, more than 6,000 records into it. Now consider this particular purchasing document is something which is residing into your SAP system, and the ZEKQ is giving you the purchase order which are external purchase order created somewhere, and it is getting synced into the system. If I want to get this set of data into a single select query, okay, but I want that this particular set of data should be appended to each other based on some sort of condition, saying let me just observe the data over here. What we do have MARC DV01, everything is available over here. And here I do have DV01. Do we have anything? Yeah, we do have 3 records. Here we also do have 3 records. That's nice, and it's the same, it seems. We have 7700. So we have many things. Out of which we would be selecting some sort of data based on something. So we would be selecting some set of data from 2 tables. So I'll just say select EBLN, BUKRS, BSART, BSTYP, and ER name. From we would be selecting, let's just say EKQ for the first. And after selecting the data from EKQ, what we want is we want to specify it for some sort of dedicated table. So I'll just say, give me the data coming from a particular company code, I guess. Which particular company code I can rely upon? 7700. Does it have? Is it there? So we have 3 records over here. And I guess here we do have only 1. That's a good thing. Okay, it's only, there are also 3. What is the difference? Do we have some sort of payment term, discount? What is this? This is a status. Okay, so this is a status which we have over here, and here we do have a status as well. Let's just select some sort of data. For example, I'm selecting a set of data from here where my BUKRS is equal to, for example, let's just say 7700. And I want another set of data that should also come. Here I'm not writing into for now at least. I am willing to get some sort of data again coming from ZEKQ that I have a set of purchase order created in my ERP system, PO native, or I can say native PO created in my same system. And I have some sort of data synced and then changed, and I can say I do have it available in my ZEKQ table. We can say external POs. Now what I want is I want this 2 set of output, okay, coming from 2 different data sources, and I want to have the data available in my single output table. So what I might do is I might say into table over here, then I'll just say appending table in my second select query likewise. Instead of iterating on application server to database and database to application, I might directly say just remove the colon dot from here and just say union. Okay, so what this system would do is it would union the data from one data source and the another data source, and here you can write the output structure. So you can say into table @data, and here you can just say NT combine PO. If I do a syntax check over here, then you would be getting that you have a fresh set of select query ready with you. If I just execute here, then you are getting that even though the 7700, even though the 7700 ZEKKO EKKO table was having 3 purchase order, here also there were 3 purchase order. After doing the union, how many records we are getting? We are getting just the 3 records. We can expect that we can expect 6 record out of here, because we are having 2 data sources for this, but instead we are getting only 3 records. Why? Because the union comes with 2 flavors. You might also have faced this question multiple times into interviews, that a union is there and there is also a keyword called union all. What is the difference between both of them? When I say a union,
Check for the key union.
sorry, yeah, So ultimately union itself determines that union distinct. So union doesn't say union distinct, but internally it behaves like union distinct. It gives you the distinct records out of two select queries. And union all would give you all the set of data, definitely based on key. But yeah, I mean it union means union distinct. So when I say I want all the data irrespective I do have duplicate records or not, so I'll just say union all over here. And if I just say execute now, some sort of issue over here. I have some sort of issue over here. It should have appended. Let's just see. We'll see why it is not doing the stuff for me. I think there is some issue over here. Where is my ZEKKO and where is my EKKO? Okay. So here I do have a EKKO and here I do have 7700. Yeah, I don't have a data in EKKO and that is why. So ultimately, I got a record of 7700 only placed in my ZEKKO. So let's just take an example where we do have a data. So ultimately for 7700, I don't have any record. I have 0 records. So maybe we picked the wrong example. And here we have 3 records. And that's why output of this is giving us total 3 records, even after doing union all. If I select a company code for DV01, I guess, DV01 is also not having any sort of records over here. Okay, we do have only 1710. And do we have any sort of combined, or we can say common? It's an external set of purchase order that we are getting. So if we can get some sort of core-relevant data, let's just see if we have something common. If we do have, then so ultimately the purpose of union is same. It is ultimately getting the data, and we do have 2 flavors of that, union and union distinct. But if we have a common data, then we can get some sort of right set of example that we can get. Yeah, we have BI01 with us. This BI01 is having records over here. If I just go over here and pass company code BI01, okay, then we have 37 something something. Okay, so we have 2 set of different purchase orders. So of course, union and union all would work the same way. But here we are having BI01 1 and one BI01 over here. So it should get the data from both the tables and give me the concatenation of those, or we can say horizontal concatenation of those. It is a 13 record. So maybe 7 is coming from some, okay, 5 and 8. So we are getting 13 records out of here. But one thing is to mention over here is how the execution is taking place. When we requested for the data, we were on application server over here and we went to database server. After going to database server, system queried to all the set of tables. It's not for only 2 set of tables. You can have n number of union clauses available over here. After getting the data, the system directly come back over here and it gives you our data out of multiple tables. If I would have used appending table, I might have said up into table for the first, and then I might have said appending table. First thing. Second, we have 2 flavors over here, a union and union all. Definitely union and union all would behave the same way when we don't have a duplicate records. But whenever we have a duplicate records, what you would be getting is union behaves like union distinct. Union distinct, it means it gives you this distinct set of record based on your key, saying, okay, these are the unique records, and this is something that you were expecting in the output. So if two data sources are giving same set of output, it would be, we can say, shorted and adjacent records would get deleted. So it's like shorting and delete, adjacent, duplication, execution, even after getting the data. That is something this union would do internally. Okay, so that is a one important SQL syntax that you can think of. First thing. Second, let's just say we just started with learning our new ABAP syntax is over here. Inline declaration and everything is still fine. The union keywords and everything, this we are talking about right now. These are the queries that we wrote in a new ABAP. But is it also correlatable, or you can say relatable when it comes to CDS? Let's just see that. So I'll just say, so of course CDS is not something that we are going to cover over here. We are just ensuring that whatever we learn, how different it is whenever it comes to a CDS view generation. So we would like to get the same set of data as a part of a CDS.
Sumit,
Till the time,
can
yeah,
the where
this,
condition be different?
yeah, it can be anything. So for example, you want to get some, okay, yeah, let me just give you one more example. Here we wrote that I can have same data source with different condition, or we can have a different data source as well. So you can have multiple n number of conditions. Let's just say you want to get BI01's data over here. On top of that, you also want to get some sort of data coming from 7700, or I can say you want to write where my ER name is equal to my SIU name.
Yeah.
So you can have n number of condition on written on n number of columns. The only crust is the data you would be getting would be after execution of all this particular set of record, and in a single go it would be combined in this table. But the only rule is you should have same amount of columns. If I just remove ER name from here, the number of elements in the union must match. Okay, so the column structure should be same each and every time. So if I do have 5 columns, and if I do have one column less over here, then that is something which is not going to work. I can have a combination. Here I do have a union, which is a union distinct, and here I have a union all. Here I have one data source, another data source with a set of columns, and here I do have a separate data source. Anything is possible. Where do I have that particular guy? Eclipse. Yeah, it's over here. CDS is something that, of course, we won't be going too much into detail today. Instead, we would be going with a.
I think we have CDS in the second or third week. I guess you'll be covering complete CDS.
Exactly. Yeah, we have it in the session number 4. So
Yeah.
3 sessions we would be dedicating to the new ABAP. All we want to
Okay.
ensure is the open SQL we are having over here, is it aligned with the CDS or not?
Okay.
So let's just say I want to create some sort of CDS. We would be going in detail how you can set up the Eclipse environment and everything. Okay, very soon before we start with the CDS. Currently, for creating a CDS, I'll just say create new, and here we do have under core data services an option called data definition. That is something I am choosing, and let's just go with a local package for now. And here I'll just say I'll just say as it's a local, it won't ask you for any sort of transport request. So this is the first CDS that we have with us. We did nothing. We just say create and data definition. It just got created. Here, our main point of focus over here is how the CDS is aligned with that of the normal ABAP syntax that we are talking about. So here we have two components. So I'll just first introduce you with the family. So we have here we have something called a CDS view entity. This is the CDS entity which is lying at the database level. Whenever we are creating a CDS, it also creates a SC11 level, or we can say DDIC view at the same time. The name of it would be given in a web catalog. So whatever is starting with @ is called annotation, and here it is a name of the SQL view. So here I'll just say SQL view. Now we have our query ready. So yeah, of course, this annotation we would be just quickly going through in some time. Let's just first focus on what we started with. So we have something called a syntax. So here we have a syntax bit altered. Here we have a select from and then data source, and then we have a curly bracket which expect the list of columns. Here we have a select, and along with that we have columns, and then we have the data source. So this syntax is ultimately having a repositioning. That is how a CDS behaves, because it is having its own editor, its own set of rules. So here we would be specifying the data source as we specified. We can specify the list of columns that we need. So I'll just specify the list of columns that I need. And then we have to go with the same set of information. So here I am specifying where. Okay, so I'll just copy this down over here and just paste it over here. Here you would be saying that it behaves a bit different. We are getting some sort of error. So let's just identify what are the errors. We are specifying a where clause over here. But if you see, we have specified EQ. But if you see, we are on a ABAP editor, and that is why we are saying a very minimal amount of translation would occur from a syntax when it comes to a ABAP level SQL and the actual RDBMS SQL syntaxes. So this EQ is a ABAP level SQL syntax. Ideally, RDBMS or database understand the symbolic characters equal to, not equal to, like this. So we have to replace all this EQ with a equal to like this. Okay. Then if you see, I have specified a comment like this. In ABAP, we used to specify comment. So that is all ABAP level concept. So this double inverted comma has to go, and it should be replaced with some sort of double slash. That is our comment is specified over here. It should be a, sorry, single equal to, why I specified double one. Now, the portion over here, the system username, is something which is something that we would be covering as a part of a session user. So currently I'll just remove this because that is not of our interest for now. Okay, so we do have a SAI username available with us. And here, if you want to provide any sort of terminator, you have to use semicolon. So we have our code. All we did is we have the data formatted in a just one upper, one lower case, one upper, one lower modules, we can say. We have a select and data source, and then list of the columns, and union that we learned over here. The same would apply. Union all that we learned would also apply the same way. Okay, and if I just activate this, we have some set of data we can expect. If I just execute, there is a button for execute in Eclipse. If I just say ABAP application, it would execute it and give you the set of data in the output. Okay. So mostly if you see this template, you would be given, and you have two sections, and you would be getting all the particular separators and everything as you have specified it in your we can say open SQL syntax over here. It would be 80 to 90% same. Okay, and that is why the open SQL syntax that we are using, it won't be limited to the new ABAP. It would be used in a new ABAP and the CDS and the AMDP. All of those use new ABAP syntaxes. Okay, then there are certain annotations. So @ is something which whatever start with @ is called annotations. Here we have certain technical level annotation called ABAP catalog. Whenever we think of ABAP catalog, you can think of a SE11. So at SE11 level, we have multiple annotation, ABAP catalog level annotation. So this is my SQL view. If I want to copy this and just see in the system where I can see the view, then you can copy the name of an SQL view. So this is your SE11 view which is getting created. So I'll just say, and here you would be getting the view that you created. In the selection condition, you would be getting the condition that you passed. Okay. And the data sources. The particular CDS view that you are able to see over here, that you would be finding in over here in the DDL source, and you would be having it over here. But the crust over here is that we would be more aligned with what we are learning. And this annotation is something that we would be seeing more detail whenever we would be learning the CDS views. I hope it makes sense till now. Or anyone is having any question, you can ask. Okay. Now, let's just.
It's clear.
Okay, perfect. Thank you. Now, the last but not the least thing that we would be seeing over here, and then we would be going with certain built-in function of a new ABAP syntax is very. So we would be seeing that we have this particular code written. Is it creating any sort of database artifact? When I say a database artifact, do we have any sort of TADIR object directory entries dedicated for this select query? No. If I want to make this global, I might write this in a CDS view like I did over here. And if I have this particular CDS view prepared, then I can expect that not only this program, but n number of programs can also use that, right? So I'll just say how I can use this in a particular, I can say program. I'll just comment this down. Sorry. I can use this in a way that I'll just comment this down for a while. And here I'll just say select R from my name of the CDS view entity you can copy from here. And you can get it in any sort of output table. So I'll just select the same table from here. Now your whole select query is centralized. So your whole select query is centralized. You are getting the data, but it's being executed at CDS level. So this is how they are communicating to each other. They are providing the same set of data, this time not executing it at your, we can say, ABAP editor level, but instead it is stored at your CDS editor level. Okay. So it is behaving as if it's a normal table or a normal view, but it's not normal because that is something we would be seeing very soon. Okay. So this is
but
on
the execution sorry to interrupt. The execution
just,
time of writing the code at GUI level or the CDS level would be the same, right? Now, what code you have copied it at the CDS level,
it would be the same.
it would be the same, right?
Timing would be the same, but now if you see, I have one program where I do have a dedicated logic written over here. Going forward, let's just say you can think of this particular logic is some sort of customizing, some sort of switches you have in your system. What code should get executed, what should not, what is the execution flow. If I do have written dedicated to my dedicated in my one program, I have to write again and again in my another program if I'm creating and I want the same logic. Instead, if I do have a database artifact, I can just maintain whatever I want at a single place, and all of my program would get impacted, and all of those would be controlled from a single execution, single code perspective.
Okay, it's like
Right?
it's like a plugin now. If you want to add anything new, we can add it over
Exactly.
here. And just it automatically comes into a select query.
Exactly. Right.
And if we have to debug this, right, we can directly put a debugger. We have to put a toggle breakpoint in CDS and we have to execute it from here. No?
So ultimately, you can debug a ABAP program and you can debug that. For a CDS view, that is something we would be coming soon. We would be coming soon on that. Okay. Thank you. Yeah. Now, so there is something that we had till now, and we would be now going with certain SAP built-in function. And I think we have someone. Sorry, it was something else. Fine. Yeah. So now we would be going with certain built-in functions that we do have at the So when I say I am having a new SQL syntax is open SQL syntax is at ABAP level, it's not dedicated and limited to only a union clause. Okay, we have plenty of other. We have got plenty others built-in functions as well. When it comes to a string manipulation, some sort of number arithmetic, some sort of date manipulation, or we can say some sort of dynamic column generation. Dynamic, or we can say conditional column generation. So we have plenty of inbuilt function also available at your ABAP OpenSQL level. That is something we would be seeing next. So, but I'll suggest it's 10:32. Let's just have a quick 5 minutes bio break, and we'll just gather back and we'll just resume with what we are also left for today's session. I hope it is fine. Okay. So it's 10:32. Let's just gather back at 10:37, and we'll resume the session and cover the rest of the topics. Okay. Thank you. See you soon.
Okay, so yes, are we all back? Mm, okay, and I heard Siva had some sort of question, but I guess it was in chat, so I was not able to go through. So you are saying, can we use inline declaration for insert, update, delete of database table? So I can say yes, but that is something that we can see um, whenever we are in mode of an insert, update, delete. Okay, so insert, update, delete would ultimately need some sort of data source, ideally, right? So whenever I say it needs some sort of data source, you can visualize that as if I am getting a data from some sort of table. So those set sort of table you can assume and you can generate it using some sort of new ABAP syntax is value keyword. And those value keyword would ultimately you would be using for passing the data. Instead of declaring a variable, the variables would be declared inline over there. For insert, update, delete, that sort of variables we can use. Okay, that is something we would be seeing whenever we are going in the application server level syntaxes. Because DB we are updating, but ultimately the input would be application server level data source, and that should ultimately be, I guess, covered as a part of application server level syntaxes. Okay, so yeah, till now we have covered many things, and now we would be going with a one more step deeper. Let's just learn onto certain built-in functions. So you see, till date we were having many time a requirement of getting the data from multiple tables. We are getting the data from multiple tables, and after getting the data, we used to let's just say perform some sort of operation to make them ready to present them in a form which actually my end user wants. Okay, why? Because we want to perform some sort of string manipulation or number or date or any sort of operations on the data that was not possible on the database layer earlier. Here we have many powerful functions which would help us while performing this operation. At the same time, it would also do those operations while fetching the data itself. Okay, before we do have a data available with us on our hand into an internal table, the system would help us to manipulate the data and only retrieve the data in a format that we want. Okay, and for that we have certain built-in functions. So let's just create an example. Let's just have let's just say some sort of scenario. So I'll just say select options. We do have, we are getting some sort of BUKRS as an input. Here we will be specifying some sort of tables. So this is nothing but a normal selection screen design. Now, all I want is, I want to get some sort of PO data. This time I am interested in a PO data, which is not only at header level, but it's coming from header as well as line item level, right? So if we were in SAP ECC, I might have get the header data, then might have checked the initiality of the same, then would have went for a for all entries in. Here we would be going with a joins. So I'll just say I want set of data coming from my EKKO, and here we would be using a, we can say, sign for joining multiple tables. Someone wants to say something, it seems. We will be going with a joining EKKO table along with that of the, we can say, EKPO table. So we are using inner join. So when I say I'm using inner joins, so I hope you all know the concept of join. Definitely in ECC we were restricted of using joins, but the joins is something which is a kind of a non-detachable part of an SQL.
Okay, so whenever it comes to a joints, we would have a inner join and a outer join. Outer join also comes in two flavor, a left outer join, a right outer join. When I say inner join, let's just say I do have a set of data, for example, column 1, or I can say I do have a column and the data, for example. So I do have a key 1 and I have a data 1, I have key 2, data 2, and key 3 and data 3. Let's just say I do have a line item record for the same. So this is my line item table for, let's just say, column, and here it is another column, and so here I do have, let's just say, key 1 and let's just say key the key 1. So for k1 I can expect I do have two records. So here it is joining on this. Here I do have some sort of data for let's just say k2. We don't have, let's just say, data for k2, we do directly have it for k3. And then we have a data for, let's just say, k4, for which there is no header records, a hypothetical scenario. So when I say inner join based on this column and this column, I can expect the records based on condition, which says this particular column of first table C equal to table number B's column number C. So here it would just get the record coming from the entries which are matching based on the key. So I do have K1, I do have K1 also matching over here. So this would become part of my output. For K2, there is no line item record, so it would be excluded from the output. For K3, we do have a line item record, so it would also be part of my output. So this is something that I can expect as a part of my output data, because we are going with an inner join. Okay. Because we are going with something called a inner join over here. When it comes to a left outer join, gives you all the data from a left hand side table. So I would get all the data from left hand side table and only matching records saying, okay, K1, K3, but K4 is not there in the table on the left hand side. So we would be only getting this particular record which are selected over here. When it comes to a right outer join, the right side of the table, which is there on the on condition, would get the priority. Okay. Here we are going with a inner join. When I say on EH, we would be ultimately joining the table. So here we would be saying I want to join the table based on EBLN, EP, EBLN. So you see, we are using a tilde sign over here. And I want to select the data saying from header I want EBLN. Okay, and from line item, let's just say I want EBLP. And here I want Metna, for example. Here I want some sort of, let's just say, short text. Likewise. So for now, we'll just take these records, then we would be getting more fields if we need. And we are storing the data into table. And here I can say data, LT, PO data. And we want only the records where actually we are getting the, so based on the input that we are getting from the user. So I'll just say where my S underscore BUKRS is the one which would be providing me the input, but I'll be passing it into my EH BUKRS. And here we would be using the red S BUKRS. So this is my okay. So we are having this set of input coming from my user and I'm getting the set of data. Now to have a proper view, let's just generate a ALV. And we are getting data from LTPO data. I'll just display the records.
So here we use inline declaration, which is also application server level inline declaration. Okay. If I might not be using new ABAP, what I might have done is I might have gone into this method, copied the name, or we can say type of the variable. I might have initialized this variable and then would have used this. Object-oriented new ABAP syntaxes gives us a liberty that whatever are the importing parameters to the program, of course, it would be exporting to the method, but importing parameter to the program, you can have an inline declaration as well as a receiving parameter for the program. You can also have an inline declaration for. We would be going into detail in the upcoming session where we would be learning inline declaration from the for the application server variable as well. If I just say execute and I want to get the data from 1710, here we would be getting the set of data presented in a well formatted output. Now let's just start with very important functions over here. So let's just start from here. So let's just say I want a dynamic column generation. So definitely it's very simple. When I say a dynamic column generation, we can have any sort of random column generated. But if I want to have some sort of column giving us the data based on the condition, saying if this is the kind of input I'm expecting, then this is the kind of output that that is something that should be there in the output. For example, let's just say here, let's just open some sort of table. Let's wait, maybe there is some issue with the server.
This concept is similar to what we discussed in the demo class, right? By having a field dummy, where with respect to any instance we can have it.
Yeah, you can have it. So that is a dynamic column declaration, definitely.
Yes.
But yeah, other than that, we have few functions which we have not declared, or we can say we have just declared discussed few functions. There are plenty of them which are left.
Okay.
But let's just wait for a minute. Is there an issue with the server? Just a minute. I'll just ask the server team to look into it. Just allow me a moment. Okay, so we do have the server back. Nice. So the program is locked. Let me just unlock that. Okay, so we are going with some sort of dynamic column generation. Okay, we would be keeping it dedicated to a conditions. So we are just opening the data available to us. So we have plenty of data, out of which let's just say I want to go with some sort of data which gives us okay, let's just say 1010. So I want an output which says, let's just say company code is something which the user may not be able to remember that hard and fast, and I don't want to give them a short text as well. I want to give them some sort of descriptive text based on condition, saying if I'm writing a case statement which says it seems like an application server syntax because that is what it proposed, but we would be using as we want. So I'll just remove this from here and I'll just say end case. So this is my end statement. Here we have a when clauses. So we can have n number of when clauses. Okay, and we have any sort of else clause. So else is the default one. So we can say when my view carriers which I am having, if it is 1710, then consider this as some sort of Indian plant, or we can say Indian company code. If it is not 1710, instead it is, let's just say 1010, then consider is some sort of European plant, European company code, and else you can say it is others. And this is a case statement that we are writing, which says there are multiple conditions and after ending you want to assign this set of output to something else. So I want, if I after execution whatever output I'm getting, where actually I can expect this output to go, what sort of internal table column it should generate. So we have to give a name to the internal table column that would get generated. So I'll just say end as some sort of custom column. You can have any number of name that you want to give, because you are saying as, and when I say as, it's an alias, and alias can be anything. Let's activate over here, and if I just say execute, here we are getting data from 1010 1710. We just, for analysis purpose, let me just activate certain ALV functions. So we are having n number of company codes. So here we are getting European company code, Indian company code, and n number of others as well. Okay, so we generated a column which was not there in the database, and that particular column is now being represented in my output conditionally. Okay, that is why it is called a conditional column generation. And if you see, what we generated over here is a conditional column, but here we didn't have any sort of variable on which we are putting the switch. I put a condition based on BUKRS. If I want to put again a condition based on the generator of the purchase order, saying okay, if it is not from this two company code, then again check one more condition which is saying ER name equal to let's just say, is it my user? Then I can say my user. Okay, so ultimately there is no switch over here. So this particular condition is called a condition column without pilot variable. Why? Because there is no pilot for this particular condition to get executed. Instead, if I just say case, and here I'll just write EHBUKRS, that when it is 1010, then it should say then this particular condition is getting executed dedicated to a particular column. Okay, and this particular column's value would determine what would be my output. So this is something I can consider a conditional column based on a pilot variable, or we can say pilot column. So there are two flavors of specifying a dynamic condition columns. One is called without a pilot variable, one is called with pilot variable.
whatever data that are coming, if you want to based on column, you want to generate something, then you can use this flavor. So you can choose based on your requirement what sort of output would ultimately mean best for you. So I can say this is my option of how I can generate dynamic columns. Again, this server. Okay, fine. Next thing we would be learning over here. Yeah, please.
Can you just explain this without pilot variable based on pilot column?
So ultimately, if you see, I have a case statement over here.
Yeah.
I am
Yes.
putting a condition. Now, while putting a condition, I can put a condition on n number of columns, right? Saying I have a condition on BUKRS, I have a condition on ER name, and that's why I have to write whether it's equal to, not equal to, an n number of whole code. Instead,
Yeah.
for a particular column's value, based on, I'll just keep on monitoring the value for this column, and based on that, I'll just determine. So I'll just say, okay, case and EH So what is the value of BUKRS? Likewise, we would be giving the value to the output. I'm not writing
Yeah.
equal to and anything. So here I cannot incorporate something. We should also check my ER name and BUKRS at the same time.
Okay.
So this is not. So ultimately, at case level, you don't have a column, but at when level, you have a condition. Here
Yeah.
at case level, you have just put a column name whose value would determine what would be your output data.
Okay. Okay.
That is,
Okay. Yeah. Yeah. Okay. I have understood.
okay, thank you. Now, next thing is uh, very important, string manipulation. Because till date, what we were doing is, for doing any sort of string manipulation, we were mainly depending on a loop and a field symbol and on the string manipulation function, which are available at the application server level. Very simplest one, if we start with, let's just say I do have a short text. So let's just let's just go where actually this code belongs to. So we do have a short text available over here. And here I want to, have, let's just say this short text, I want to get it translated to a lowercase, for example. So I would write a string manipulation function whose name is called lower. And here I'll just specify eptxz01, and it would ultimately give me the string converted to a lowercase. Now, as soon as you start making your select query complex, you would be getting a error from a HANA database, and that is why if you see, whenever I'm writing a select query, this is why I have actually put intentionally this where clause, just to show you, whenever you are having a select being written and it is getting complex, you should always use this into at the end, because you are going with an inline declaration. Inline declaration ideally gives you two information. First is what is the name of the column. Second, what is the data type of it. Third, what is the length of that particular data that would come. Now, as it is a dynamic declaration, system would determine all of those things from the actual set of data that is actually being generated by all the conditions, and we can say all the operations that you are performing. Okay, and that is why the generation of the internal table should occur at very end, after filtering and everything has occurred, to ensure that optimal memory allocation is happening. Okay, and that is why if you see, the into and appending clause must be at end of the select. That is what HANA ideally follows. So this is something that we should be following going forward. So into is something that we would be writing very at the last. If I just say over here, now my query would work, because system would identify, okay, for some BUKRS you don't want data at that particular point in time. If I don't have any sort of output coming, then I can allocate very minimal memory to it. Okay, so this dynamic column generation, or we can say the new SQL syntax, gives the system liberty of saving the memory. Okay, and that is why the into table should be at the last. If I just say execute right now, so here you would be getting that this short text which we had over here is now converted to a lowercase. Let's just learn some sort of more SQL function for string manipulation. Let's just say I want to go with some sort of concatenation, saying this EPTXZ01 that we had over here, I want to concatenate it with some sort of, let's just say, some sort of custom characters I want it to get concatenated it with. So I'll just say concat char. And if I just say activate, what I just did. Oh, sorry, they're used. So ultimately we have to ensure that a space is there, because the system won't, if it's continuous, then system would identify it as an input. Okay, so ultimately here system concatenated the short text along with the short text that we are passing. If we want to give some sort of space in between, here the character is directly getting appended. Instead, if I want to give some sort of space in between, then I do have one more set available, which just say concat with space. If you see, we are getting concat with space, and this particular concat with space, here you can pass three parameters. First, what we are ultimately passing over here. Other than that, we would be passing how many space you want. So let's just say I want three spaces in between. I can say concat with space. So here we are getting three spaces between the strings that we are concatenating. Now let's just say I want to perform two operations at the same time. I am translating a string to lower. I am getting a concatenation. Now let's just say I want to convert this concatenated string into a lowercase. Okay, so for example, I want to say this particular whole string CWS, or I can say, let's just say concat char, which is getting generated. I want to translate it to lower. So if I just say lower, and here I pass concat char as concatenated lower string. If you do the syntax check, you would be getting that this concat char is not a known column. Okay, because this is all dynamic column generation. So system won't be knowing if there is any sort of column available at design time. System would only come to know that this particular column is there or not only at runtime. And that is why you cannot use this. So what you have to do is you have to instead use the piping of multiple functions. So here I do have a concat char. So if I want to do the lowercase translation also, even after concatenation, you have to use concat. At the same time, you have to use lower on the same data. So ultimately, you are piping multiple operations in the single one. Okay. So now your data would be concatenated first, then translated to lower, and then it would get assigned to a final output column. Okay, so that is what system would ultimately do for you. So you would be getting the concatenation as well as lower translation of the data getting at the same time. So there are plenty of such more SQL functions for string manipulation. These are the most frequently one. You would be going with a next one. For example, we want to go with some sort of date manipulation. You want to go with some sort of date manipulation, for example. So when I say I want to go with date manipulation, let's just pick some sort of date. So for example, I am getting EH, sorry. So let's just say I do have a header record which is having some sort of date for the purchase order creation. We say creation date, and at line item also I do have some sort of date which is a change date, for example. As we do have two dates, let's just say I want a statistics which says how many days are left, or we can say in after creation of the PO, after how many days the PO was actually changed. So I can say dates, days between, and here I can pass the EH date over here because the right side column is not known till runtime. This is just for illustrative purpose. I am writing a name, single name. So here I can say how many days are left after once after the PO was created and it was changed. So if you see, I had 15th of June when this PO was created, and then on the same date it was a change. If I just short it to the descending, you would be getting that okay, on 12th of Feb it was created, and on 10th of September it was changed. So it's a 941 days after the PO creation it was changed. So ultimately, all the date operations I can also perform over here. Let's just say I want to observe that after my PO creation, in 7 days I want to observe something. So let's just say after PO creation I want a date which is coming just after let's just say 7 days after that. So I'll just say days, add whatever I want to add. If I want to month, if I want to add month, if I want to add days, anything I want to add, I can add that. So here I'm adding a days, let's just say. So I'm saying EHA date over here, and I'm adding, let's just say 7 days out of after that. So I'll just say days added. So if you see after 15th, after 7 days, there is a 22nd date which is coming. And just say if we have some sort of month end date somewhere. Yeah, so here there is a 26th of March, and after 7 days, it's the 2nd of April that would occur. So ultimately, all the date level operations, be it adding a days, being adding a month, and everything, that particular database can now take care of. It's not the complex functions that we used to do. So ultimately, we used to have some sort of functions also that we used to use when ultimately SQL was not sufficient, or you can say capable enough for doing that. We used to use certain function modules, we used to call those, and ultimately it would give us some sort of data operations being done. Here, that particular operation can be handled directly on the database level. If you want to do some sort of mathematical operations as well, or you can say numeric operations, then of course those are also possible. For example, I have some sort of gross price or something, let's just say. Okay, it's EP. Okay, you. So we do have some sort of gross price, and here I want to do some sort of mathematical operation. Let's just say I want my user is saying give me all the gross value, but just round it off. Don't give me whole value. So I'll just say okay, round off the data and give it the rounded value till 1 decimal place. So I'll just get the rounded value over here. Let's just say I want a ceiling value. Let's just say I have what 10.51. Okay, 10.51, and its ceiling value would ultimately be the 11. If it's 10.49, then also it would be for 11. But if it's a floor value I'm deriving, then of course it would be reduced to 10. So those ceiling function, floor function, everything are also possible on the database layer. So if I want to get the ceiling value, or if I want to get the floor value also over here. Okay. Let's just say I want to get some sort of absolute value without measure. Many a time what happens is if I am saying 10 into -2, then it becomes -20. But what is the absolute measure? Absolute value of the same? Okay, it would be the exact value without considering the sign of that. That is consider it as an absolute value. So I'll just see if I want to get the BRTWR
and I want to get the absolute value out of those, then also that is something I can derive via the database directly. It makes sense many a time. Oops. Yeah, it makes sense many a time whenever we are having some sort of difference that we are deriving from multiple operation. Sorry. So I wrote EL everywhere. It should be EP. P is for EKPO. Okay, so if I just say execute now, so here we would be getting that we are having a gross value, and this gross value ultimately is now rounded off to one decimal place. Here it is 38. 38 rounded off to one decimal place is 40. Same way we have a floor value. This is a ceiling value. This is a floor value, and this is the absolute value that we are getting. So these all the operations that we ultimately use to perform an application server can now also be done on a database. And the functions that we are ultimately covering over here are also not limited to this. Ultimately, these functions can also be, there are plenty of such functions. These are the most used functions. In future, let's just say if we are getting a requirement of having some sort of other operation, then we can also have n number of such functions evolving and we can use those. Okay, so ultimately, this SQL built-in functions library is versatile. The crust over here is we can have these operations perform on the database side. Okay, I hope it makes sense to everyone. Okay, perfect. So,
So it's one.
yeah, please.
For this new functionalities which are there, right? For date manipulation, string manipulation, do we have any directly SAP portal library link where when we are starting the practice, we can check it from there as well?
So ultimately, there are standard SAP documentation available, okay, that we can
Okay.
use, and that would ultimately help. If I just try to get something over here as well. Okay, so if you see one big library, the
Yeah.
one with which we are spending the life all these years, the SQL built-in functions, you can have any sort of functions that you want to get a help of. Just
Okay.
F1 and the task is done.
Yeah. Okay. F1 on the key field.
F1 on whatever function. Let's just say I want to get the information of a lower.
Yeah. Okay.
Okay, perfect.
Okay.
Thank you. Yeah. I think I'm getting one more question from Shiva. Okay. Okay. It's a yes. Okay, good. Now, so we did this particular thing over here, and let's just get back to the agenda for today's session. So we discussed certain things which are saying on the limitation that we discuss that we are having a list of data types which are predefined, and for that, of course, we can't go with the inline declarations. We have one more options, or we can say one more limitation. Let's just try to go with that as well if it's possible to achieve. For example, let's just say I do have Z tab 01. Sure whether you can achieve that, but let's just try. Um, so we do have Z tab 01. Let's just see there is also one more limitation, whether we are trying, let's just try to achieve that, if we can achieve that as well. There is a very known error. Okay. So let's just say I am trying to get so ultimately what happens is many a time the operations that we are performing, okay, many a time whatever operations that we are performing over here gives us some sort of issues whenever we are going with a data type which are non-compressible. So for example, I am having some sort of, let's just say, purchase order. Okay. Now, based on this table, I want to derive some sort of output, for example. So what I am just writing is if my LTKKO is not initial, the old syntax that we used to write, select, what was the name of the table that we created? It's LT tab 01. Okay. So if you see, we are getting a error warning over here. Okay. I'll just remove this and put it over here as we discussed it earlier. But here our main focus is over here. You remember we discussed that whenever we are going with a non-well-defined columns at that particular point in time, the data compression is getting impacted. So if you see columns with type string, row string, LRWO, LCAR should not be used in the select clause due to distinct semantics. Whenever I'm going with for all entries in, at this particular point in time, your data would be compressed. Okay. And that data compression can only happen with the well-defined column wherever data type and the length is specified. But if you are going with some sort of string and content type of columns, at that particular point in time, the optimization of the data won't happen. So if you see, this column prevents from optimization from being made on the database table. And that is why the columns that you are defining at the database table, wherever possible, it's always a good habit to avoid the string, row string, or we can say non-well-defined column. This column should be avoided. We should always use the columns which are having a fixed length wherever possible. Wherever it is not possible, definitely there we don't have any option. And after introduction of HANA, it was converted into a warning. Earlier, in lower version of SAP ECC along with HANA database, this is ultimately turning out into an error. Okay, all you can do over here is you can just convert this particular syntax into a older syntax, and then you can use that. Okay, because the SAP ECC on HANA database, okay, is not allowing this at all.
as HANA is ultimately ignoring this because rest all the things it is trying to get executed in a faster manner, and that is why it is just giving a warning. But many a system you would be getting the same thing, but it would be into error, and that's the solution to that would be you have to define the output table that you want, and you have to avoid the new syntax, and instead you have to go with the old, because data compression is not getting triggered whenever an old syntax is being followed. Okay, and that is the only solution that you would be able to achieve whenever you are going with a SAP ECC on HANA. So there are multiple projects which are going on SAP ECC on HANA. This is a kind of behavior that you would be observing. Okay. So there you have to just declare a data type, or again then you can say Z tab 01. Now why it is calling that selection list should be separated by comma? Because you are using into table at last, and into table at the last line suggests that there is a new syntax that you are trying to use. So this warning which you are getting over here, this would turn into warning in an old syntax in SAP ECC on HANA. Currently, I'm on S4 HANA, so I'm ultimately getting the warning in both of them. Okay, but yeah, so ultimately, this is ultimately hampering your data compression. That is the main focus which I want to just highlight over here. So that is the main focus of this discussion. Okay, so that is also one of the limitation of HANA. Now, if you see, we have two things that we would be we are left with, and those are quite related. The programming methodology that we are yet to discuss, the procedural and OOPS, and it's also relevant to application server. And then we have two things, deep diving into the new ABAP, which are also helper and condition variable. These are also part of your new ABAP syntaxes 7.4, 7.5 application server syntaxes. Okay, so we can plan to consider that as a part of upcoming session, where we would be discussing and starting with this particular topic and going in that particular direction. So we can consider this now for as the end of the session. And if you have any question, we can discuss, else we can close the session as well. Anyone is having any question or any doubt or any suggestion, feel free to discuss.
So
Yeah,
I had only 2 points. Okay.
yeah, please.
Yeah, from my perspective, for more clarity, na, if there can be any 10 minutes of ramp up, how the data flows in ECC and how it is in S4, na, it would make us more clearer. How the data flows when it was in ECC, it would have been at application level. Then the database, we would have written a select query at application level. Then a database would have hit. And what happens in S4 now?
So ultimately, that is something that we discussed.
Yeah.
But yeah, if you see here,
We are
we were discussing.
I was still, I have still doubts on it. So if you 10 minutes the session, 10 minutes of discussion on this in the next call, I think it will be more clearer.
Definitely. So we can discuss, okay, where actually what sort of code that we are writing would hit the database, and when ultimately the control would come back to the application server. So it would be more clear how we can ensure that most of the execution cycle we are pushing on the database. Definitely, that's a good point. We'll be having a.
If this thing is strong, if this thing is cleared, means whatever manipulations we are doing after that in the select query, it will be very easy for us.
Exactly. Perfect. Yeah, that's a very good point. So I'll be just having one example, and that particular, as a part of that example, we would be having a clear vision on where actually we are on the execution cycle, which is getting executed on application server, and which cycle is getting executed on database.
Yeah.
Consider we'll be going through that definitely. Anyone else having any suggestion, any point, or any questions on what we covered till now? Okay, then I guess we can consider this as end of the day, and we would be again meeting in the upcoming session. Okay, and I'll be sharing the recording for today's session. And yeah, in between, if you have any questions, just feel free to.
Next Saturday, right? The session would be
yeah,
next Saturday.
It would be on next Saturday and Sunday. Each Saturday and Sunday. We started with Sunday, but we would be having session on each weekends, same time.
Yeah.
Amit,
Oh,
if we
but
currently like a SAP ECC and we have to migrate to HANA, So
Mhm.
if they change only database, is it possible? And how the query, I mean, whole codes will work?
So ultimately, whenever I am changing, or you can say we are going with a data migration, or sorry, not data migration, system migration. At
Mm-hmm.
this particular point in time, certain syntax would change. But if you see, not only SAP, but each of the technology giant are going with a code upgrade, which is a downward compatible. So your 90% of the code which was there would be compatible. So whenever you are going with a code change, at this particular point in time, what you have to ensure is the obsolete syntax are ultimately removed and replaced with the correct one. Let's just say hint keyword is there. That is something that you should be replacing. At certain point in time, HANA is very database, or you can say type strict. So let's just say if I'm on ECC, material number is now converted from 18 to 40 characters. Certain data, certain quantity fields are also changed. So at that particular point in time, you would also have to change your code in a way that the type consideration is getting considered. For that, we have a inbuilt ATC check given as a part of your HANA, where the basis team would be creating a copy of your system, and you would be getting that ATC checks and code inspector getting executed. And whatever level 3 warning that you are getting, sorry, level 1 warning which you are getting, you have to just clear those out, and that would ultimately help you. But it doesn't mean you have to rewrite your whole code. Only the portion which is containing the syntax which SAP is getting, which SAP is getting, or you can say considering as a obsolete, which won't be part of the HANA, that is something you have to change. So it would be 10 to 15% of your code change, not 100%. For that, ATC checks and AC, we can say HANA code inspector check can help you out.
Mm-hmm. So it will be for all program we have to do when we do this upgrade.
So that particular check would get executed at a package, or we can say whole system level. You do not need to list down all your program and execute it one by one.
Okay.
Instead, what you would be having is you would be having a SCI where you can pass the package. You would be having a whole system that you can pass in. Whole system would be scanned in a one go. Okay. Otherwise, it would become hard, because many a time what happens is I am listing one program, I'm just leaving one
Hmm.
by mistake or anything, and then it would be a trouble while migrating. So no, it would get executed at system level.
So this is the way it will get migrated.
Exactly. Yeah. So migration procedure ideally takes place in a cycle of months. What ideally they do is your whole SEC system's transport request would be imported into your sandbox HANA system they are preparing for a trial. Once it is imported over there, they would ask you to execute your ATC checks. That is a part of our technical normal ABAP team, or we can say our technical lead also. So they'll ultimately execute those, and we will be having a list of errors or list of things that we should be taking care. And our target would be to just close and short down those lists. That would be one part. Second thing that you would be taking care of is in ECP ECC, for certain functionality we might have implemented certain SAP nodes. Now those SAP nodes might be also included in the HANA package that you are taking, because earlier in SAP ECC we required to implement those nodes because we didn't have that particular version, or didn't have that supported code including in our ECC package. In HANA, if it is already there, then you have to do some sort of SPAV and SPDD activity, where you would be ensuring that okay, your custom code is written, at the same time the functionality which was there in the ECC is also working. So those PAV and SPDT activity is also something. So these are the two things: one custom code migration and one upgrade SPAV and SPDT activity. These are the two things that would come into picture whenever we are going with any sort of HANA migration project.
I didn't get the second one. What is the note? It will work in
So
HANA? Like,
okay,
uh,
okay. Consider you are on SAP ECC, and in SAP ECC you want some sort of functionality which was not delivered as a part of your SAP ECC. You know that this functionality is possible. So you raise an OSS with SAP, and SAP provide you some sort of SAP note. Now afterwards, while introducing SAP HANA, SAP has included this note as a patch in a SAP HANA. So this particular HANA version already contains the fix that you have implemented as a part of SAP note that you have implemented. So this SAP ECC is having, let's just say 171089, this particular SAP note implemented, and this particular system don't need that node, because ultimately what this node might be doing is in your, let's just say, some sort of CL ABAP, or we can say CL ABAP XYZ program, on line item number 10 it might be adding one more condition based on your requirement. Now HANA version is having that upgraded code already available in their particular HANA version. So do you need this note? No, because what this note is doing, it is doing some sort of code correction, but that code correction is already included as part of SAP HANA. So what you have to do is you have to perform some activity called as SPAV and SPDD. This SPAV and SPDD activity would check the upgrade or the nodes that you have implemented, the enhancement that you have done as a part of your SAP ECC system, and now you are trying to move to SAP HANA. So are those short of upgrade already considered in the patch version which SAP HANA has included as a part of its release? If it is there, then you can reset this node because the standard execution would take care of that. If something is being taken care by standard, then of course we should not go with some sort of enhancement, right? And that is why this PAV and SPDD would give you two option of, let's just say, resetting, or we can say adjusting your code, and that is something you can decide upon. And that is why this upgrade activity would contain two steps, PAV and SPDD. But as soon as you open your transaction, it would become more clear. So if you are on HANA, you can open the SPAV and SPDD, and it would become more, the picture would become more clear what you have to do. You would find two buttons for reset and adjust. You would find the list of SAP nodes, those you have had implemented earlier, and you can check what is the code that you can see in SAP ECC and what is the code that you would be seeing once you are migrated to HANA. And you can finalize whether you want to go with the HANA code or you want to go with the code that you had for your specific requirement.
Okay, fine.
Yeah, so I guess this is it for today's session, and we'll see each other in the upcoming session. Okay. Thank you so much for joining. See you. Bye bye.